Welcome everybody. This is going to be our vertex form of parabola homework review, part one. And so we are going to be covering a different way to, in this case, find the equation of a quadratic function besides the standard form of ax squared plus bx plus c. And so we'll go over steps here. And if you find this helpful, definitely because we see this not only in our classes, but also in some standardized exams and stuff. And it's helpful for maybe questions later on, especially when they have word problems that involve quadratic equations. Because a lot of stuff happens at the vertex, right? And if you can, really appreciate if you hit the like button if you find this helpful, and leave any questions or comments in the comments section below. All right, everybody. So the first question is going to be use information provided to write the vertex form equation for each parabola. Now, the vertex form, some people write down the following. I write down this way: y equals a times x minus h squared plus k, where the vertex is going to be h comma k. Now, I've seen people do y minus k equals a times x minus h squared. Now, the idea is that I'm using this form, and if you use a different form, okay, it's okay as well too. Just understand in this case that h comma k is your vertex. Now, we can find the vertex by completing the square, but I have a tendency to use the axis symmetry, and you've seen on the videos and all that the axis symmetry in this case is super helpful for us. Now, the formula of axis symmetry really is going to be in this here. X equals negative b over 2a. Now, why is helpful? Mainly because we can identify the a, b, and c values from the standard form of the quadratic equation. Our standard form quadratic equation looks like this. Y is equal to ax squared plus bx plus c. Right? And so the goal is to be able to find the x value and then to plug the x value back into the function to find the matching y value. Once we have that, we have our a value, our h value, and our k value. We'll plug into our formula, and we should be okay. So we want to identify, in this case, the a, b, and c values here. And so for our first question, a looks like the coefficient of x. Now, a is the coefficient of x squared. Number multiplied squared is going to be 1. Now, students say, well, I don't see any number there. Well, it's not 0x squared, because 0x squared would be no x squared. Because see 1x squared there, a value is 1. Our b value is 16, and our c value is 71. So now we're going to plug into our formula for axis symmetry. X is equal to negative, and I like putting parentheses here because I want to make sure I have the form correct. And then, of course, I'm plugging the right numbers in. And so b is 16, a is 1. I have here negative 16 over 2, which is negative 8. So we have our x equals negative 8 as our axis symmetry, which I'll label as AOS. Very important component for the vertex, because now, once we find the x value, we're plugging back into our function here. And so we want to find the matching y value. So y equals negative 8 squared, based upon the function we have top here, plus 16 times negative 8, plus 71. And so now, y is equal to 64. Now, 16 times 8, that's going to be 80 plus 48 is 128, but it's negative 128 plus 71. And 64 minus 128 is negative 64 plus 71 is equal to a positive 5. So y equals 5 for the matching x equals negative 8. So why is that important for us? Because our vertex now, which is made up of the axis symmetry value of negative 8 and the matching y value of 5, is going to be helpful. Now, the important parts of plugging into your formula are going to be, in this case, the a value, the h value, and the k value. So we might want to kind of list them here on the side so that we just plug into our formula. A, h, and k. Now, the a value we found is same a value from before is 1. the h value is going to be the vertex of the x value of the vertex, so that's -8. And our k value is going to be the y value of the vertex, which is 5. So now we're going to move up a little bit here, and now we're going to plug into our formula. And so as y is equal to, open parenthesis for the a, x minus, I do a bracket for the h, close parenthesis squared, plus open parenthesis, which for the k. And now we fill in. Y is 1, h is -8, and k is 5. When we simplify all this, we get y is equal to 1 times, now x minus -8 is the same as x plus 8, squared plus 5. And this is going to be the vertex form of our parabola. I'll make this full page here so you guys can take a look here. Okay. Okay, so let's try another one, right? Same technique. All right, again, make sure you have the axis symmetry written down, the formula written down in your notes, and of course, in this case, the steps we took, right? Our first step was to find our A, B, and C values. We then used them to find the axis symmetry, which is the x value of the vertex. We then, after we find x value of vertex, plug into our function to find the matching y value. And then we use A, H, and K, the x and y values, H and K are x and y values of the vertex, to plug into our formula. Now for number 2. Here it's a little bit different. It's like, oh, do I have to multiply everything? Well, a couple of things. We could do that, no. So if we multiply everything out, we're going to get y is equal to x squared plus 4x plus 5x plus 20. And so we are going to get, in this case, y is equal to x squared plus 9x plus 20. Not a problem here. And so what we can do here is, again, use our axis symmetry. We're going to find our A value to be 1, our B value to be 9, and our C value to be 20. Okay? So begin with the axis symmetry. X is equal to -b over 2a, or x is equal to negative of 9 over 2 times 1. Now, this will mean that x is equal to negative 9 over 2, or negative 4.5. Okay, so now in this case, you're saying, oh, no, decimals. Don't worry about it, though. We're going to use our graphing calculator, plug stuff in. So really, we're plugging in, find the matching y value of the x value here. So x is negative 4.5. Don't forget to use the negative symbol, not the subtraction symbol. So negative 4.5 squared plus 9 times parenthesis, negative 4.5 plus 20. So let's use our calculator, shall we? All right, here we go. We're typing a calculator. Now again, parenthesis, use the negative symbol, negative 4.5, close parenthesis, squared, plus 9, open parenthesis, negative 4.5, close parenthesis, and then plus 20. And we get, in this case, the value of negative 0.25. So that's our matching y value. Now, for the record, we also can rewrite this as negative 1 over 4. Just like we write the x as negative 9 over 2, but it's fine, right? And so either way, we know our a value in this case is 1. Our vertex in this case, so we'll write down the vertex now. So the vertex, because we now have x and y value, negative 4.5, comma, negative 0.25. Or if we want to, we can use, in this case, negative 9 over 2, comma, negative 1 over 4. Which one's better? I personally like to use fractions only when there's no repeating decimals and such, so we're not rounding off anything. But either way is fine. Now, our formula, y is equal to a times x minus h squared plus k. All right, and so here we go. We're going to fill in here. Y is equal to open parenthesis, x minus, do a bracket for the h squared, plus parenthesis here for the k. And we're plugging in. A is 1, h is negative 9 over 2, and k is negative 1 over 4. Now what we got to do is clean this up a little bit, and so now we get y is equal to 1 times x plus 9 over 2 squared minus 1/4. I would also be okay with if you use decimals and did 1 times x plus 4.5 squared minus 0.25. Both of these answers are correct and acceptable. All right, just to let you guys know, that's what, if I was giving you a question on a test, this is what I would see. Okay? All right, and keep in mind in this case that, just when we're doing these here, is there another way to do this? No. Yes, the idea is that could we have figured out that the axis symmetry was going to be, in this case, negative 4.5? Well, that would definitely, in this case, could happen because we can find the roots in this situation to be negative 5 and negative 4. And halfway between them be negative 4.5. But I'll use this for now, just so that we're a little more familiar, and we'll maybe get a little more, use a little more finesse when it comes to these things. Now, I will let you guys know that we're not going over every single question on the sheet because of the fact that, well, you guys got to practice those. So I picked the first one, and I picked number 8 because it was a little bit different. But all the other ones are going to be very similar in this situation, though. Okay? And again, if you have questions, maybe you have suggestions, please leave them in the comment section below. I would love to hear what you guys think thoughts on this, because this is the end of our Vertex form of parabola home review part 1. All right, please give a like, and again, if you found this helpful, and of course, if you have more questions, just ask. Okay, we really appreciate that though, because we do have some questions coming up for your midterms, and we just want to know how to do these, especially beyond our math class. Thanks so much for watching, ladies and gentlemen. I just want to let you guys know, I am going to try to do a some type of raffle if we hit the 200 subscriber mark. So if you have not subscribed yet, ladies and gentlemen, all right, if you have not subscribed, please hit the subscribe button and turn notifications when new videos are added. I will be trying to do a kind of giveaway at the 200 subscription mark, and I'll give instructions as we go along. Probably one of the things I enjoy is a Funko Pop. All right, and I have an extra, probably Line Friends brown Funko Pop, the standard one, not the one that's not the Funko Shop exclusive though, but this one's pretty cool if you like brown. All right, and so as we go along, we'll have more of these things as well too. Thanks so much for watching, everybody, and I'll see you in the next video. All right, everybody, take care and be safe.